The problem states a semicircle of diameter 1 sits at the top of a semicircle of diameter 2 as shown. The shaded area inside the smaller semicircle but outside the larger semicircle is called a lune. Determine the area of this lune. So basically, it's just telling us to find the area of the shaded part. Well, we can connect this first. We can draw two lines right here and make it like a cone shape. Okay, so if we connect these two, it'll make the problem a lot simpler because we broke it down into pieces. I'm gonna let this part be A, this part be B, and this part be C. So if we want to find A, it's basically taking the whole cone shape thing. So A plus B plus C. And then you want to subtract the whole cone shape. Subtract this part of it to find out A. So subtract B plus C. So this is what we're trying to find. And A, B, C, and the B plus C, they all represent the area. Well, instead of trying to figure out what the whole cone shape is and then subtract BC from it, we can split this up into A plus B minus B plus C plus C. I just rearranged it because you'll find out that trying to solve for this is a lot easier. So we can start off with the first part, which is A plus B. Well, A plus B is just the area of the smaller semicircle with diameter of 1. So to find out that, we find out the area of a whole circle, which is pi r squared. And in this case, A plus B is the semicircle, so it's 1/2 of the whole circle. So it's 1/2 pi r in this case. It tells us its diameter of 1, so radius would be 1/2. So it'd be 1/2 squared. And this gives us 1/8 pi. And then we're trying to figure out B plus C. So it will be this part is what we're trying to figure out right now. Well, as we see here, we know that this is the center. We drew it from the center, right? And so these are all radii. So it would be, those are all 1. And we know that this line right here is 1 because that's the diameter of the smaller semicircle. And by the way, we know these two are 1 because it tells us that the diameter of the whole semicircle is 2. So radius would be 1. So if we know that this triangle C, that is an equilateral triangle. So we know that the degrees would all be 60. Well, if this is 60, B plus C is just a segment, or it's just a quarter of, not specifically a quarter, but it's just a part of a whole circle. It's a sector. So we can find out the area of the whole large circle, and then this tiny part, B plus C, is just 60 degrees over the whole circle, which is 360. So it'd be 60 over 360 times the area of the whole larger circle, which is pi r, in this case is 1 squared. So this would reduce to 1/6 pi. Now we want to find just C. Well, C is just the area of the triangle, the equilateral triangle. Well, with any equilateral triangle, you should probably memorize like the ratios, but in this case, if you don't know it, that's completely fine. We know that the sides are 1. We can draw a line down, splitting this base up. So this is 1/2, and we're drawing the perpendicular line, so that's a right triangle. So this is 1/2. This is 90 degrees. We already know these are 60 degrees because it's an equilateral triangle. So then that means that this little triangle right here is a 30, 60, 90 triangle. 30, 60, 90 triangles, I highly recommend you know the ratios of each side. The hypotenuse is always 2 times the smaller base, and the longer side is always going to be that smaller base, in this case 1/2, and then times the square root of 3. So we know that to find out the area of a triangle, it's always base times height divided by 2. In this case, we know the base is 1 times height. We figured it out. It's the square root of 3 over 2 times 1/2, which is square root of 3 over 4. So that is what C is. And now that we figured all this out, we can just plug it into right here to figure out A. So it would be 1/8 pi minus 1/6 pi plus square root of 3 over 4. So this would be, find the common denominator for 1/8 and 1/6, which is 24. Okay, so the answer is C.